最后一个是不太重要的错动性断层，它有一个东西是重点，是我这边写的中阳极的转型断层，这在高中重要，但国中没有教，所以国中又变得不重要，只讲一件事，背完就好了。什么背完？就是这个美国加州的圣安德烈斯断层叫做错动性断层。有人看加州大街的电影吗？有啊，就这个，对吧？圣安德烈斯断层，对吧？好，造成所谓的地震，它这就是一个错动性断层。好，所以它被人家表过了，这个错动性断层的地震不会那么大，不会那么大。这个是香港的一个说法，香港的说法就是聚合性有人消失，叫破坏性的交界。张列性有人生成，是建设性的交界；错动是互相摩擦，既没有长新的，也没有老的消失，所以既不建设也不破坏。但是因为摩擦断裂，所以仍然有很多地震。所以美国加州会有很多的地震，所以他拍的电影叫做《加州大地震》，虽然有蛮多要腐烂，没关系啊。加州大地震就是这样子，就是这有一个太平洋板块跟北美的错动性，不过这里蛮麻烦的。美国那边呢，在一个小区里面有张列、有聚合、有错动，还好我不是美国人，不用这么复杂。
明天落后。
你看，待会会有影片，一个往上走，一个往下走，错动性的交界。好，就是在那边断层的照片，断层照片。好，这就是我们那个可爱的影片。就会发现旧金山跟洛杉矶以后会变成一家人。好，就是 America 的这一边，这边呢就咱们讨厌，这里有张列、有错动、有聚合。然后呢，就这里太平洋板块跟北美板块。然后呢，两地现在分开，下面洛杉矶，上面旧金山的是在大概400-500万年、600-700万、800-900万年以后，就变成邻居了。这边邻居在隔壁，因为错动性的关系，这就是跟你讲它的错动交界。国中生只要背，国中课本的内容就只有圣安德烈斯叫做错动性断层就没有了。转运断层我等一下会跟你提一下，我等一下会跟你讲。好，这里是有 TEDEd 的影片，跟你讲地球分层的板块，上面有点小错误，让我再跟你说。
Once upon a time, South America lived harmoniously alongside Africa, until a crack in the earth drove the two continents apart. This breakup began about 200 million years ago, during the separation of the supercontinent known as Pangaea. Their proximity back then explains why the same plant fossils and reptile fossils like the Mesosaurus can be found on the South American east coast and African west coast. However, this evidence does not account for how the continents moved apart. For that, we'll need to take a close look at the Earth below our feet. Though you may not realize it, the ground below you is traveling across the Earth at a rate of about 10 centimeters per year, or the speed at which your fingernails grow. This is due to plate tectonics, or the large-scale movement of Earth's continents. The motion occurs within the top two layers of the Earth's mantle, the lithosphere and asthenosphere.
他就画错了，他那个软流圈没有到地核内，它就算不按照比例，它最后只能画上面那个比较淡的橘色，不能画到下面那个深的橘色的地方，它没那么大，听懂我意思吗？它那个范围画错了，就是它里面出现了一个小小的错误，上面就是右手边连接就是地壳跟上部地函的一小部分。不过瑕不掩瑜，就原谅他。
The lithosphere, which includes the crust and uppermost mantle, comprises the land around you. Beneath the lithosphere is the asthenosphere, the highly viscous but solid rock portion of the upper mantle. It's between 80 and 200 kilometers below the Earth's surface. While the asthenosphere wraps around the Earth's core as one connected region, the lithosphere is separated on top into tectonic plates. There are 7 primary tectonic plates that compose the shape of the planet we know today. Like the other smaller tectonic plates, the primary plates are about 100 kilometers thick, and are composed of one or two layers, continental crust and oceanic crust. Continental crust forms the continents and areas of shallow water close to their shores, whereas oceanic crust forms the ocean basins. The transition from the granitic continental crust to the basaltic oceanic crust occurs beyond the continental shelf, in which the shore suddenly slopes down towards the ocean floor. The South American plate is an example of a tectonic plate made of two crusts, the continent we know from today's map, and a large region of the Atlantic Ocean around it. Collectively comprising the lithosphere, these plates are brittler and stiffer than the heated, malleable layer of the asthenosphere below. Because of this, the tectonic plates float on top of this layer, independently of one another. The speed and direction in which these tectonic plates move depends on the temperature and pressure of the asthenosphere below. Scientists are still trying to nail down the driving forces behind this movement, with some theories pointing towards mantle convection, while others are examining the influence of the Earth's rotation and gravitational pull. Though the mechanics have not been sorted out, the scientific community agrees that our tectonic plates are moving, and have been for billions of years. Because these plates move independently, a fair amount of pushing and pulling between the plates occurs. The first type of interaction is a divergent boundary, in which two plates move away from one another. We see this in the Mid-Atlantic Ridge between South America and Africa. The next interaction is when two plates collide, known as a convergent boundary. In this instance, the land is pushed upward to form large mountain ranges like the Himalayas. In fact, the Indian plate is still colliding with the Eurasian plate, which is why Mount Everest grows 1 centimeter per year. Finally, there's the transform boundaries, where two plates scrape past one another. The grinding of the transform boundary leads to many earthquakes, which is what happens in the 810-mile-long San Andreas Fault. The moving Earth is unstoppable, and while a shift of 10 centimeters per year may not seem like a lot, over millions of years, our planet will continue to dramatically change. Mountains will rise, shorelines will recede, islands will pop up. In fact, one projected map shows the cities of Los Angeles and San Francisco on top of each other. Maybe South America and Africa will come together again too. Only time will tell.
这个影片在线上交流网站上有，你可以再去看一遍，就是跟各位解释有所谓的板块交界的状况 ，OK 吗？就是跟各位说一下，有人有问题不？无，很好。